Welcome to the continuation of coordination. So far, we've looked at the introduction, the endocrine system, the nervous system. In this video, we're going to take a look at the brain and also drug addiction. Then after that, we're going to take a look at one sense organ, which is the eye, and another sense organ, which is the ear. We're not going to discuss all the sense organs, as some of them we have already dealt with them in other topics. Like the skin, we dealt with it when we were talking about osmoregulation. So we are going to concentrate on the eye and the ear. So the brain. We discussed before that the brain is part of the central nervous system. The central nervous system is made of the brain and the spinal cord. So let's just concentrate on the brain since that's the main topic here. So the brain is divided into three regions. Okay, so the first region is the front part of the brain called the forebrain. This is made of the cerebrum, the hypothalamus, the pituitary gland, and the olfactory lobe. The mid part of the brain is called the midbrain, made of only the optic lobe. Then the last part of the brain is called the hindbrain, made of the medulla oblongata and the cerebellum. So these are the three main regions of the brain. So we're going to visit that. Let's just take a look at a picture of a human brain. Then we visit each of these parts. We see how they are connected and their functions. So we're going to start with the parts that makes up the forebrain, which are the cerebrum, the hypothalamus, and the pituitary gland. We're not going to discuss the olfactory lobe as it is beyond the scope of our syllabus. So the cerebrum is this part. So all this part is called the cerebrum. Okay, so the cerebrum is the center of intelligence, the center of thought, consciousness, and all. So when you're doing mathematics, all that happens in the cerebrum, memory and all those activities happen in the cerebrum. Okay, so after the cerebrum, we have the hypothalamus, which we discussed before, to be in charge of osmoregulation. It controls the amount of water in your body, the amount of temperature, and the likes. Okay, then after that, we have the pituitary gland, which we also discussed that it's a master gland, and that means that it stimulates other glands. Okay, so these are the parts that makes up the forebrain. Okay, the cerebrum, we're going to visit it. We discuss it in details. As you can see, there's a gray part here and the white part here. The gray part is called the gray matter and the white part is called the white matter. Away from that, we have got this part here, which is called the midbrain. So the midbrain is connected to your eyes, or the part of the midbrain, the optic lobe, is connected to your eyes, meaning that it is in charge of the sensation it receives from the eyes. Then the last region of the brain is made of, which is the hindbrain, is made of the medulla oblongata and the cerebellum. Okay, so the function of the medulla oblongata is it links the rest of the brain to the spinal cord. So it links the rest of the brain to the spinal cord. It is also in charge of some automatic activities like heart rate, breathing rate. You don't you don't consciously control your breathing rate. When you are breathing, you don't always know that you are breathing. Okay, so that happens like it's automatic, just like heart rate. So that is always pumping blood. So that happens automatically, and such automatic actions are controlled by the medulla oblongata. Then we've got the cerebellum, which is in charge of coordinated movement. So coordinated movement are movements where more than one part of the body has to participate, like dancing. When you are dancing, you need your toes to be doing this, you need your hands to be doing this, you need your hips to be doing that. So such kind of actions need the different parts of the body to work together. That is controlled by the cerebellum here. Okay, even posture, the way you stand and all that is the cerebellum. So these are the different parts of the body, of the brain and their functions. So let's just visit them again now, this time a bit slow, so that we just amplify on what we've discussed. So we start with the medulla oblongata, which I said the function is to link the spinal cord and the brain, and also conducts nerve impulses between these two parts. Okay, because of this, it also controls automatic processes such as heart rate, breathing rate, swallowing, salivating, sneezing, and coughing. Next is the cerebellum. So I've started with the hindbrain. So the cerebellum controls coordinated movement, like I said. It also helps maintaining posture. It controls the sequences of activities involved in dancing, acrobatics, and playing of musical instruments as examples. Next is the hypothalamus, which is regarded as the center of homeostasis, meaning that it controls taste, hunger, and temperature, thermoregulation. So the pituitary gland we discussed, we know its functions, but I'll just emphasize on one thing here, and that is it links the central nervous system and the endocrine system. It's like it belongs to both systems. Okay. As you can see, we're discussing it connected to the brain, which is part of the central nervous system, which means it's part of the central nervous system. But it also secretes glands, which are part of the endocrine system. So it links the two systems. The next is the cerebrum, which is the one we're going to discuss in details. So the cerebrum is the largest part of the brain and is the center of intelligence, memory, language, and consciousness. It has both motor and sensory areas. The motor areas have motor neurons and the sensory areas have sensory neurons. So the motor areas control voluntary movement. Okay, so a voluntary movement is a movement where an individual chooses to do something. You want to lift a book, that's a choice you make to lift that book. So that's a voluntary movement. The opposite is involuntary movement, where you do things without thinking about the things. Okay, so the motor areas, they control voluntary movement. Well, the sensory areas interpret sensations. So when there's something that has happened in the environment, the sensory areas are going to receive signals, and they'll interpret those signals. So injuries to the cerebrum lowers a person's intelligence, though there have been some cases where someone became more intelligent. Anyway, I won't go into those details. Maybe not intelligent, but their memory their memory improved after some injuries. Don't injure yourself so that you pass exams. No. All right. So it is divided into two halves, which are known as cerebral hemispheres. Okay. So the outer part is gray in color because it contains cell bodies of neurons. Well, because of this, by the way, it is called the gray matter. So the inner part is white in color, as it is made of axons and neurons. So the inner part is just as axons and neurons. Well, the outer part has cell bodies. Because of that concentration of cell bodies, they make it appear gray in color. Well, the inner part appear white. Because of this, it's called the white matter. Next, we concentrate on drug abuse. So what's a drug? A drug is any externally administered substance which modifies or changes the rate of metabolic reactions in the body. So anything which you put inside your body from the external environment and then changes the rate of metabolic reactions in the body is called a drug. So drugs may be administered in several ways, such as first, injection. You can just put a drug in your mouth. You can put Panadol in your mouth, so that's injection. You can also do an injection where you use needles and syringes to introduce drugs into blood. You can also sniff blood, which are in powdery forms. Okay, you can also inhale blood. Okay, taking a vaporized drug in through the respiratory. So you just inhale it through your nose. So these are different ways in which you can administer drugs. So harmful drugs are also called drugs of abuse and are classified into the following groups. So by the way, drugs are not all harmful, but some are harmful. Those ones which are harmful are classified as drugs of abuse, and they can be grouped in the following ways. We have stimulants, depressants, hallucinogens, narcotics, and inhalants or solvents. So we're going to take a look at maybe 3 or 4 of these. We look at the examples, how they affect the body, and the likes. So let's first get acquainted with some terminologies that have to do with drug abuse. The first is dependency or addiction. Dependency or addiction. What does it mean? Dependency or addiction is a condition where an individual's body fails to function normally in the absence of a particular drug. Okay? So if a given drug is not in their bodies, they cannot work normally. So that means your life or that individual depends on that drug, or they're addicted to that drug. The second terminology, by the way, a person who is dependent on a drug is said to be addicted to it, like I've said. So the second terminology is tolerance. Okay, so this is the condition where an individual needs a higher dosage of a drug to produce an effect that was initially being produced by a smaller dosage of the drug. You hear some people saying, me, I can't get drunk by drinking 1 bottle of beer. What basically how you should understand that is their tolerance has changed. They need more for them to get drunk. So that is called tolerance. Then also we have withdrawal symptoms. So these are the symptoms or signs an individual experiences when they discontinue using a drug which they are addicted to. Okay, so when someone wants to quit using this drug when they are addicted to it, then they are going to have certain symptoms. So those symptoms are called withdrawal symptoms. Classes of abused drugs. Now we'll go into the different groups of abused drugs, and we see how they work, how they affect the body, some withdrawal symptoms, and the likes. So the first are called stimulants. From the word stimulants, these drugs have to do with stimulating body activities. So these are drugs that accelerate or increase the rate of impulse transmission in the nervous system. Okay, so when there's a stimuli, the time it takes for your brain or for your central nervous system to detect that there is something that is happening is increased. So you become hyperactive when you have stimulants in your body. So examples of stimulants are cocaine, caffeine, and nicotine. So what do they do in the to the body? They increase alertness, they increase heart rate and breathing rate, they reduce the desire to sleep. You always want to be active, you can't sleep. They reduce the desire for food, you won't have appetite. They make someone feel energetic as if they have power. And they make someone have a sense of euphoria, which is a feeling of well-being. You feel good, you feel things are okay, feel things are nice. So that fake feeling of well-being is called euphoria. So this euphoria comes in when someone administers stimulants. So what is the negative effects of administering stimulants? So they increase the risk of cardiovascular diseases such as hypertension and coronary heart diseases. Also, prolonged use can lead to dependency. You don't have to depend on a drug as a person. Okay. Also, they can lead to liver damage. You keep on using them, your liver can end up being damaged. Overdose can cause death. Next, we look at the kind of opposite to stimulants. These are depressants. So depressants, they depress things, they make things slow and short. Okay, so these are drugs that slow down the rate of impulse transmission in the nervous system. Okay, examples of depressants are alcohol and heroin. I think now you can even picture Okay, for stimulants, we're talking about cigarettes. Nicotine is found in cigarettes. So we gave an example of nicotine, which is a substance that is in cigarettes. So someone who has smoked, they are alert, they look sharp, and the likes. But for someone who has taken alcohol, everything slows down. When they want to move, they want to walk, they are going to be interpreting the signals very slow, and they are going to be misjudging. Okay, so alcohol and heroin are depressants. So their effects include reduced anxiety and tension. So the tension in the body, the anxiety is going to be reduced. Increased desire for sleep and drowsiness. In small amounts, some cause an increased desire for food, opposite to stimulants. Also, they make someone have a sense of euphoria, just like stimulants. Also, they numb pain by inhibiting pain and emotional centers, meaning that if you feel injured, you won't feel the pain. Okay, so they make sure that they inhibit pain and emotional centers of the nervous system. So, what are the dangers associated with abuse of depressants? So, the first is overdose can lead to instant death, just like stimulants. Injectable drugs such as heroin increase the risk of HIV infection resulting from sharing of needles. Addiction or dependence is quickly established also. They have severe withdrawal symptoms such as vomiting, diarrhea, and dizziness. If someone hasn't taken beer, then they'll be vomiting and the likes. So these are severe withdrawal symptoms. They slow down the time taken to respond to stimuli, leading to accidents. For example, someone is driving, they see someone crossing the road. Instead of stopping the vehicle, it will take time for them to interpret, for them to realize that there's someone in front, they are going to cause an accident. So they slow down the time taken to respond to stimuli, leading to accidents. So they can also cause damage to vital body organs such as the liver, kidney, and brain. Okay. Remember the diseases we talked about, such as cirrhosis. So those might be the results of drug abuse. Also, they can increase social problems such as crime, prostitutions committed by addicts who need money for the drugs. So we're going to zoom in into a specific depressant, which is alcohol. We want to know the harmful effects. Okay, so the harmful effects of alcohol can be classified as either short-term or long-term. So questions do come in an exam, which are structured like this. Describe the long-term effects of alcohol abuse. So you need to know which ones are long-term and which ones are short-terms. So short-term effects are those that are experienced immediately after taking the drug and do not last for a long time. So these include staggering. Okay, when you drink alcohol, you'll be staggering, slurred speech, antisocial behavior such as shouting, slowing down of transmission of nerve impulses, thereby slowing down the access to stimuli, thereby accidents, poor judgment, hangover. So long-term effects are the effects someone experiences after using a drug for a long time. So they include permanent damage to internal organs such as the liver, brain, and kidneys, the hardening of liver tissue resulting from alcohol abuse, which we discussed before as liver cirrhosis. Also, it can the long term can be a social problem such as poverty, since you are addicted to drinking alcohol, so all the money you prioritize them on alcohol, so you can end up being in poverty, lack of food in homes, failure to sponsor children to school, and the likes. Another big problem are stomach ulcers, also uncontrolled shaking, okay, which is called delirium tremens, and hallucinations in some cases. Okay, I think this is known fact. When someone has drank for a long time, you will see them shaking even when there's nothing to make them uh, shiver. So that's one of the long-term effects of alcohol, and also hallucinations. So another one, for expectant mothers who take alcohol have a risk of giving birth to underweight babies having a syndrome called fetal alcoholic syndrome. So this is a condition where a child is deformed and mentally retarded. So the last class of drugs we're going to study are hallucinogens. So from the word, this cause hallucination or distortion in perception. So these are drugs that distort the perception of an individual. Perception means how you see things. To distort is to make sure that is to affect how something happens, so to put it. So these drugs, the way you perceive is going to be affected. You're going to be seeing things that are not there. You might not even things that are not there, sometimes you might not even see them. So that's what hallucinogens do. So two examples of hallucinogen are marijuana and LCD. LCD is lysergic acid diethylamide. So these two can distort one's perception. The long term, the effects of hallucinogen, we're not going to go into details. The main concentration of the syllabus, depressants and stimulants. And we're going to take a look at one disease, which is called tetanus, to conclude this part. So for tetanus, we're going to look at the effects of its injection. So tetanus is an infection caused by a bacterium called Clostridium tetanus. So it is characterized by sustained contraction of muscles, which leads to stiffening of the body and eventually death. So the body is going to become stiff and someone can end up dying when they have tetanus. So individuals who have deep cuts with dead objects on their bodies, e.g. accident victims, are at a high risk of tetanus infection. Okay, as a result, they are given anti-tetanus injection which contain antibodies that counter the effect of tetanus toxins. So that marks the end. So the tetanus part is part of the syllabus. So it is expected of you to know the effects of tetanus injection. And this marks the end of this part. See you in part 4 of coordination, where we're going to start the eye.